So that's how you calculate the Fréchet distance. You make this free space diagram consisting of cells where every cell individually is quite easy because it's just a line segment versus a line segment. Then you use dynamic programming to get from one cell to the next. And you look at the borders and you see, can I get from this cell to this other cell? And you only care about the borders because within a cell, you know that the free space is convex and you can do whatever you want. This still doesn't actually solve our actual map matching problem because there we said we have a GPS trajectory and a road network. So in the next video, what we'll do is we'll look at a free space and a parameter space for a polyline and a graph rather than two polylines. Another thing to notice is that we only solved the decision problem given epsilon. We're not actually optimizing epsilon. So now here's a question. How do you solve the optimization problem? How do you find the optimal epsilon? Well, the obvious answer, of course, is binary search. But this is a little bit tricky because then we need an upper bound and a lower bound to start searching with. And that's actually not that difficult. We can come up with an upper bound and a lower bound. You can think about it, but it's not that hard. But here's the thing, how long do you keep binary searching? Is there maybe a finite set of values of epsilon so that you know that the maximum must be achieved by at least one of these points? Or how does that work? You could, in practice, of course, do it to some finite precision, but that's not really cool. So then also your runtime gets to depend on the precision that you need. So the really good way that you solve this is with a thing called parametric search. It's kind of advanced. It's actually pretty cool, but I don't think we'll have the time to get into it. Maybe I'll upload a video about it afterwards, but don't count on it. It's not exam material how this works precisely, but the idea is it's kind of a binary search, except that you know that you actually find the exact solution. For this algorithm, you can get it to work.